figure of merit of DSB can be calculated. Like figure of merit, I have seen shown here the power spectral density. What is power spectral density is being already discussed by me in my previous lecture on random variables and process. So if you don't know the power spectral density, please go through that lecture and you'll come to know what exactly the power PSD of a signal is and how it is being calculated. Moving further, we have the PSD of a baseband noise signal, and which is n naught omega. The input signal we can be calculated by a square by 2. The input signal power over the noise power is a square upon 2 n naught omega, and similarly is the output power. So the figure of merit is 1, and which is not affected by any change in phase. To calculate a DSB-SC signal, moving further, we have calculated the DSB signal already, and now if you are calculating a DSB-SC signal, you can see it's AMAC by 2 cos omega C minus omega MT plus omega C plus omega MT. That is, it contains only the sidebands. Kindly look at the steps that has been explained over here very clearly, and in further, like in frequency domain, it will be represented by XFM plus FC plus XFM minus FC. So that will be the whole representation. Now, if you see over here that if our message signal is like this, and when it is modulated in frequency domain, it is almost like a Gaussian bell curve. When it is modulated on a high frequency signal, it has two sidebands. At the output, one of the sideband, this is the spectrum. This is a spectrum that I was talking to you about earlier. What a spectrum was near the low frequency, right? The zero of the spectrum, if you can remember. I think you can. And this is the process how we demodulate. Now, demodulation of DSB-SC, as I have already discussed earlier, with the help of envelope detector or a rectifier. If you don't understand, if you couldn't recall it, then please go few minutes back and you'll definitely get what were the two different demodulators that I have talked about. Moving further, how to demodulate a DSB-SC. The reconstruction of the original signal is done by multiplication of the incoming signal, followed by a low-pass filter. The synchronous detection or coherent detection is used to restructure the original baseband signal, which are in phase to the original signal. The local oscillator carrier at the receiver in frequency and phase coherent synchronism with the carrier used at the modulator. Now we